Hello, everyone. Thank you so much for joining us today's session. My name is Marilyn Lau, and I am with the USC Viterbi School of Engineering Admission and Student Engagement team. So it is my pleasure today to welcome you to today's session of our Spotlight series, where we will be highlighting our graduate degrees in Systems Architecting and Engineering. We are joined by Professor Azad Madni, who will be sharing, some more information on the degree programs, and then we will be going through a interactive, kind of frequently asked questions structure. And then we are also joined as well by Luis Ceballos, who is, the Director of Student Affairs, and he will be contributing to the Q&A session as well near the end of today's webinar. So thank you both, Professor Mani and Luis, for your time today.
Thank you, Marilyn.
So, just some quick facts for those of you, who are, watching this live right now. We will be sending a copy of the slides after the presentation. So there is a lot of information that we will be going through today. So there is no need for you to jot these down immediately if you don't need it. We do ask that you do allow around 1 to 2 business days for us to get that email out. And for those of you who are watching the webinar at a later time, please note that the content is from April 12th, 2023. We do always recommend for you to visit our website for the most updated information. And also in terms of questions, so we highly encourage you to ask any questions that you may have during the session. You can type it within the Q&A panel. Any questions regarding, admissions or, Dan Viterbi, I can definitely answer those. But, if they're more pertaining to, the program itself, both Professor Madni and also, Luis can also answer those. So for today's program, I will just go through relatively quickly, USC Viterbi School of Engineering, and then we'll go ahead and, get into the frequently asked questions with Professor Mani for the Systems Architecting and Engineering programs. And then followed by that, I will, talk a bit about the Dan Viterbi delivery method and the enrollment options that we do offer. And then we'll go ahead and wrap up today's webinar with the Q&A session. So, really quickly, it's really top level of the University of Southern California. So we are the oldest private university in the Western United States, founded back in 1880. With Viterbi School, being one of the oldest, schools within USC itself. In total, there are almost close to 50,000 students and, a lot more graduate students and undergraduates, which is combined of, master students and also doctoral PhD. There are over 4,700 full-time faculty, including also adjunct faculty as well, who also just bring in a breadth of expertise, from their work experience into the classrooms. And USC itself is a very, very diverse, when it comes to student population. There are individuals and students who come from all different walks of life, from different industries, from different cultures, all over the world, they would come to USC, which really brings diversity and inclusion as well. And for those of you who don't know, where we're located, USC is located in Los Angeles. So Viterbi School at a glance, we are made up of 8 academic departments. With the systems architecting, engineering, being one of the programs that are housed under astronautical engineering. And then also in terms of faculty, we have 189 tenure track faculty, over 33, TT NAE members, over 90 of them are, National Science Foundation Career and National Presidential Young Investigator members as well. Viterbi is also a leader in funded research. There are over 35 research centers, and our research centers are very highly interdisciplinary research centers, in which more than $213 million are spent in research expenditures annually. if you're interested in research that is offered or the different research centers, I do encourage you to visit our website to learn more of the different research centers that we have. And student population as well, as you can see here, is quite similar to, the overall student population of USC in general, where our graduate student base is almost triple the number of our undergrad. So now let's talk about Professor Azad Madni. So he is the executive director of our systems and architecting engineering program. As you can see, he has so many credentials, and most recently, he was also, awarded in 2023 the National Association of Engineering Gordon Prize recipient. For those of you, who aren't familiar with this award, it's actually the engineering education's equivalent of the Nobel Prize. So, that is just amazing. And also, he is also the member of, the National Academy of Engineering. And so, welcome, Professor Azad Mani, and thank you again so much for joining us today. So I will go ahead and now, pass the torch over to you for you to talk a little bit more.
Okay, you can go ahead to the next chart. So first of all, I'd like to welcome all of you students. Want to take you on a little journey through our program. I want to start off with certain books that you see here. And the point I'm making here is that many of the books that we have written are really used as textbooks or reference book in our courses. So it makes it much easier. So for example, SA 549 that you see on the left is the entry course, it's your on-ramp into the program. And we have a book that supports that, trade-off decision and system design. And then you have, to the right of that, you have transdisciplinary system engineering. And this book supports both SA 549, which is system architecting, as well as model-based system engineering, a pretty hot topic, as you all know. And then to the right of that is SA 546, and we have a book on that called Disciplinary Convergence and Systems Engineering Research, and that book supports that. So you can see that we have worked hard to create the best content that we could for our students. And the unique thing about our content and our courses and our curriculum is that the courses are not stovepiped. They're connected to each other. So when you acquire knowledge in connected form. You don't have the onus of trying to put it all together in your head, because we work hard to show the connectivity points between the courses and between the concepts in the various courses. Go on to the next.
Okay, so, the first question I have for you, Professor Bani, is, what makes the systems architecting and engineering program so unique?
Yes, so first of all, I want to kind of give you a little bit of a history, a little story. The program was founded by Eberhard Rechten, who was the CEO of the Aerospace Corporation, a former DARPA director, and the individual who pioneered the Deep Space Network when he was at JPL. Ed passed away several years ago, and after a period of treading water, I came on and took over the helm of the program. So we had kind of an interim phase where we had some interim faculty teach, and they did a good job. And then I came on, and I was recruited for this position, and I came on and took over the program, and have been, leading it since 2009. So these books that you will see, written by Eb Rechten and myself, are required text for the course. The important thing to know is that we have several fellows of several professional societies. So we have, IEEE that most of you are familiar with, the Institute of Electronics and Electrical Engineering. We have 10 plus faculty members. We have 7 plus faculty members from the International Council on Systems Engineering, 2 of them who are from the American Institute of Aeronautics and Astronautics, and myself, I'm the one who's also a fellow of Institute of Industrial and Systems Engineering. We are very active in several professional societies, primarily in INCOSE and AIAA, and we are the co-founder And every 3 years, we host the Conference on Systems Engineering Research. You see that as CSER, CSER. That's the Conference on Systems Engineering Research that was co-founded by USC and the Stevens Institute of Technology in New Jersey. And now this has become an international conference and the go-to place for people who are pursuing systems engineering research. Now, I'm also the series editor of the Conference on Systems Engineering Research. So every year, the volumes that come out from the annual conference, I'm a series editor of that, along with Professor Dinesh Verma of Stevens Institute. I'm also the co-founder, the founding chair of IEEE System Managed Cybernetics Technical Committee on Model-Based Systems Engineering. And this gives my students a lot of exposure in terms of wanting to publish there, in terms of wanting to attend the conferences, meet people, network, see what other people are doing, both at the student level and at the faculty level. So it's a really good opportunity for people to meet. We just completed the CSER this year. It was in Washington, D.C. Now, the thing that's unique and different about this program is that we also conduct a lot of research. I have a fairly extensive research portfolio in system engineering that dates back several years. And so I try to establish for our program and with all the other instructors, synergy between teaching and research. And what I mean by that is that our research findings feeds new material into the courses when we teach those courses. And the teaching basically uncovers new areas of research that come about, oftentimes based on questions that students ask. And so I always tell my students that as you learn from me and you go on this journey, I'm also learning from you. And so if you ask a problem, or if you provide an example, or you provide an experience, I will incorporate that and attribute that finding to you and say, here's a student that shared this with us, and I'm sharing with you guys now. We have my approach, which has actually been very instrumental in my winning the Gordon Prize, is that I use a storytelling approach, which I shared with the other faculty members, and they're also all good, very good storytellers. And so rather than just lecture on and on, we really engage in storytelling, describe concepts first by providing a story and then describing the concept. So for example, if I was going to talk to you about the global positioning system, rather than describe the parts and the functionality of the system, I will tell you the story of how the GPS came into being, starting with the launch of the Sputnik by the Soviet Union and the people that got together at Johns Hopkins, and what they went through and how it finally culminated with the creation of the GPS. And the point that I'm making is when you have a story to back up any new concept, the material becomes much more sticky. You're more likely to remember that. If I just presented you facts and concepts, you're likely to walk out of the room and forget, but you'll never forget the story. And so this is the approach we take. We also have top-notch adjunct faculty. And in 2017, the program was also named the top information systems master's program by the Masters in Data Science that you see at that particular link. Let's go on to the next. Next chart. Okay.
Oh, sorry.
Yeah. So here's some little factoids that I want to share with the master's students, because you're coming in here. Many of you are working in industry, and some of you are full-time students as well. And the typical distribution is like about 35–40% full-time students and 60–65% from industry. So we are very active with the International Council of Systems Engineering Los Angeles chapter, and we have a long-term relationship with them. When I run the Conference on Systems Engineering Research, I usually bring them to help us with all the logistics and the conference and the hotel reservations and all that sort of stuff. So we have a very good team. It's been very successful for well over a decade. We're also very active in the INCOSE LA chapter, and excuse me, and many of the past presidents of this chapter are my former students. You have an opportunity at this chapter to meet with engineers, not just in aerospace, but also in medical devices and the energy sectors and transportation sectors as such. Now, the Conference on Systems Engineering Research is a crown jewel for researchers. Here you have an opportunity to present technical and research papers, network with other researchers, both from the US and from abroad. So you get to see not just the US perspective, but perspectives from Europe and Asia and places like that. And that's very, very helpful in understanding other people's points of view. We also participate extensively in the INCOSE Los Angeles mini conference and the regional mini conference. And once again, students have an opportunity to present and network with industry professionals, students, and faculty from the LA region. Oftentimes, you can meet people who work in industry and you can make a connection with them. The next thing you know, they have a job that you're suitable for, and you can get hired by them. So these are some of the interesting things that can happen as part of this program, and as part of being a member of the Internet INCOSE Los Angeles chapter. Let's go on
Thank
to
you so yeah, thank you so much, Dr. Mani, for that. That's just very, it's very, very insightful. And I guess then, the next question would be, what programs are available within the systems in
okay,
architecting
that's right.
engineering?
So we offer both a degree program and certificate programs. The degree program that we offer is a master's in systems architecting and engineering. Okay, do you want to go to the next? All right, so this program has required courses, 15 units, and then elective courses, 6 units. On the previous chart, I did want to mention, if you just go back to that once, that we have, of course, a degree program, but we also have certificate programs. And the certificate programs, there are 3 of them. The last one is going to be replaced by another program in the very near future. But the one that we have ongoing right now, which are the certificate in systems architecting and engineering, which has courses from both the SAE program and from computer science. And so in terms of software engineering and things of that nature. And then you have another certificate program in software architecture. Okay, let's go on to the next chart now.
Yep.
So here you have program details. And for the details of the program and all of that stuff, I will let Luis Ceballos talk about that. But I will just tell you about the content of these courses. So systems architecting, SA 549 is the course that I teach. This is the first course that's taken. This is your on-ramp. So in this particular course, we introduce you to the concept of system architecting and how it's different from system engineering. And then, in addition to that, we give you a complete overview of the entire program so that you can see how the courses are connected, in what order they should be taken for maximum impact, what are the points of connection between the various courses, so they don't come across as islands of automation, islands of courses, that they're really connected. And so the knowledge you acquire. And so we give you a preferred flow to follow in the program. Now, if you run into issues and you want to make a slight change, we're flexible. We'll make that accommodation for you, because I know many of you are in industry and sometimes you need some flexibility. But we strongly recommend that you take it in the order that we recommend, because to get the maximum benefit. The next course is SA 541, which is a fundamental course in system engineering. It introduces you to the key concepts of system engineering, as, for example, covered by the International Council in System Engineering. So a lot of the instructors who teach that course use the material from the International Council in System Engineering, as well as their own material and experiences to share with students. Then once you've taken 541, you can take the more advanced course. And here you have much more quantitative methods. You have methods from decision science, operations research, and all kinds of other techniques that are quantitative that are taught here. This course is taught by a former student who went and got his PhD in systems architecting and engineering and is now teaching this course that was originally taught by George Friedman, who passed on, who was the associate director with me for a very long time, and a wonderful man, a wonderful teacher. He was the former chief technology officer of Northrop Corporation. So the advanced topics is the second course. Then the next thing is a course in the economics of systems engineering. Okay, so here we talk about the fact that you have to be mindful about cost considerations when you engineer a system. You can come up with a great design, but if it is cost prohibitive, then you have it'll have issues. So how do you take into account the economics as you engineer a system using system engineering principles? So that's what that course covers, which is called SA 560. Then you have a choice of taking one of these 2 courses, but my recommendation is to take both. They're both essential courses, and it is on the next iteration, I'll be working with Luis to make sure that these become part of our core courses, because that's what we want. We want these to be part of the core courses. So the one is model-based system engineering, which it's a very, very important subjects in systems engineering today. And the other is systems integration and system of systems integration. And so these two courses will give you some very, very practical uh, examples and experience with certain tools that will help you then apply them in your job right away. And so there's a lot of material here that is very relevant to the work that's going on in the aerospace, defense, automotive, telecommunication, and life sciences communities. Then you have some elective courses, and and these are 3-unit courses, and you have several options to choose from. You can take SA 515, which has to do with sustainability. You can take SA 546, which has to do with resilience. You can take 550, which has to do with system architecting in the political process, and so on. And then you have the technical management area. And here again, you have multiple courses to choose from. Once again, you choose a 3-unit course from one of the many options that you have here. And in all these cases, you can contact Luis when you provide your program roadmap of the courses you want to take, and he will review it for you, advise you, and if you're seeking some exceptions for whatever reason, he will then pass that on to me, and I will then make a decision if I can make that exception or not, based on what you're trying to substitute for scheduling reasons primarily. Let's go on to the next. So then we have what's called the technical specialization area. So the whole idea here is, yes, you are taking a master's degree in systems architecting and engineering, but systems architecting and engineering applies in a variety of domains. And here are some of the domains that you see: aerospace and mechanical system, AI and neural networks, automation and control systems, communication and signals processing, computer information systems, construction, and so on. Like energy management systems and manufacturing systems and so on. So in this particular area, what you'll do is, if you have a particular specialty, you will take 2 courses, 2 coherent courses in that specialty area and satisfy the requirement. And these 2 courses, a lot of people will take, for example, they want to have system engineering, but they want to specialize in the AI domain, in which case they would take the artificial intelligence and neural network courses, and they'll take 2 of them. Some people want to specialize in aerospace and mechanical system, so they'll take 2 courses in that. Others want to go into the area of engineering management, and then they'll take a couple of courses from that. So we provide a lot of latitude in this particular area. Some of them want to specialize just in systems itself, in which case the specialization would be from the courses that are taught in the systems architecting engineering program. Okay, let's go on to the next. Now here you have is the graduate certificate. A certificate is for those people who don't have the time to devote to a complete master's program, but they want to be able to keep on their lifelong learning going while they're working in industry. And this is a very convenient way to do remote learning, distance learning, and pick up a certificate on that invariably translates into more responsibility, potentially a pay raise, potentially a higher job description and things of that nature. And so what you have here, the required courses are 15 units, and you're going to be taking 5 of the courses that you see listed here. And once again, these courses that you see listed here are the courses that I covered earlier. You've got economics of system engineering, you've got project management, from the ISC department, you have management of engineering teams from the ISC department, and then you've got all SA courses: fundamentals of system engineering, advanced topics, model-based system engineering, and then net-centric system architecting and engineering, which is a course that we are discontinuing, and it will be replaced by another course, because I think cloud computing and things of that have now superseded net-centric computing. So we'll have a course along those lines as well. So remember, you are taking only 5 courses, totaling 15 units, because each course is 3 units. And so with that, you get a certificate. Now, if you really do a good job in the certificate program, you've made lots of A's and some B's, and you wanted to then pursue a master's degree, we will review that and make that accommodation for you. And it'll be the case that you will have potential of transferring some of the courses, but we will look at that on a case-by-case basis, and Luis will advise you on that if and when the time comes. A lot of students do that. They come, do a certificate, they like the program so much that they feel they can handle it, so they go from a certificate to a master's degree. But of course, master's degree has other requirements that the certificate program does not, which is you have to have a certain grade point average, and you have to have a background in one of the mathematical fields, more scientific fields, technical fields. And so if you came from something from the liberal arts or something like that, that would not allow you to get into a master's program. But we could make an accommodation allow you to get into the basically the certificate program and finish courses along those lines. So let's go on to the next. So here's the certificate in software architecture. And what you have here is you can see the first two courses are from software engineering, and they're requirements engineering and software architecture. The second two courses are from systems architecting and engineering, and those are model-based systems architecting and engineering and systems architecting. Once again, you have electives and the 3 to 4 units, and you have the choice. You have several courses you can take from here. Just some examples of the courses you can do. You have software management and economics. You have advanced operating systems, system engineering theory and practice, etc. So all those details of those courses you can discuss with Luis. And should you want to pursue a certificate, we'll try to accommodate you to give you the best fit for your interests and for your job description to the extent that we can help you. Let's go on to the next. So this is the net-centric certificate, but we are discontinuing the certificate, so I would not put much emphasis on this. We're going to be replacing this shortly, so let's move on from this.
Okay. Thank you for going through those programs, Professor Madni. So, what would you say is a type of academic background, that you are looking for in a successful applicant to the specific systems programs? And, following on that, who are some of the typical students that are admitted in the program?
Sure. So this is the application criteria, so I won't go
Oh,
into
sorry.
that.
Yeah, sorry. Yeah.
I'll give a little preamble, then we'll go into that.
Yeah.
So we are looking for people with a technical background because engineering is a technical field. So you have to have some background in mathematics, and if you have some background in calculus and algebra and things of that, of course, it's a real plus. And if you have made a B or better, then that puts you in a good place from the point of view of your technical background. The other kind of thing we look for is whether the person is in industry or is a full-time student. The way the program is constructed is that the industry people get maximum benefit, but it is also so constructed that full-time students, when they come in, are not at all at a disadvantage. And we've seen that time and again every year that the full-time students and the industry students, people who are working taking part-time, work just as well year after year, semester after semester. And so it's a very, very balanced program that we have. So the fact that the full-time students don't have industry experience does not put them at a disadvantage. This was something we worked hard to make sure that that was the case. The type of students that we're looking for are people who are interested in being systems engineers and system architects. Now, a couple of thoughts here. Engineering is a field where a lot of times you do what's called decomposition, and you decompose systems and then you analyze them. You make certain predictions based on certain algorithms and things of that nature. Architecting is more of a synthetic. It's an integrative field. When I say synthetic, I don't mean artificial. I mean integrative, that put things together. So while engineering is about taking things apart and they help in terms of analysis and before you engineer a system architecting is once you've done the analysis, how are you going to put everything together? And how are you going to make sure that you have created an architecture up front that lends itself to the kinds of things you're trying to accomplish with the system you're building? So systems architecting and engineering are complements. One is a integrative field and the other is a analytic field. And the combination of the two is what makes you a complete engineer. The type of students we look for are people who are interested in pursuing multidisciplinary projects. People who will go and work on, in the aircraft industry or in the energy industry or the transportation industry, and work with people from different disciplines, people who are engineers and programmers and project managers and logisticians and test engineers and things like that. So when you have that kind of interest, that's the kind of student that gets the maximum benefit from this program. If you look at it in terms of geometric profile or essentially a visual, uh, you are at least a T-shaped person. So you have horizontal coverage of the field through system engineering, and then you have depth, which is the vertical of the T, in at least one field. I mostly talk about people that are pie-shaped, the Greek letter pi. That means you have not just one vertical, but two verticals. And so the horizontal is what you get out of the systems architecting and engineering program. And the vertical is when you go deep into particular fields, like a mechanical engineering or electrical engineering or something of that nature. It could also be business. We have in this program, because we cover a lot of business aspects of engineering, people from the Marshall School of Business occasionally take our courses. And I've had students in my class, SA 549, where students from the Marshall School come and take courses that allows them to kind of bridge what they've learned in the business school with what they learned more rigorously in the engineering school from a mathematical perspective, and put the two together. It gives them a much better picture in terms of the job market. So the type of people that we look for then, in a nutshell, are people who would like to go and essentially manage and analyze complex systems, specifically socio-technical systems. That means systems in which humans are involved in it. So you have to have a good understanding of cognitive psychology, on human behavior under stress and things like that. Take an example of pandemic management. Why was it so difficult? It was so difficult because humans respond differently in different situations under stress and under uncertainty and things like that. So you cannot really put together a reasonable solution without really understanding how you're going to model humans and incorporate them in your overall model. And that's the area that systems engineering really excels at. And that's what will make this program so valuable and so meaningful for pursuing engineering in the 21st century. Let's go on to the next. At this point, I'm going to hand off the requirements to Luis, and he will cover the application criteria for the program. So Luis, please take it away.
Thank you, Dr. Madni. So these are just a few of the requirements for the application. So it goes similar for the graduate certificate programs and also for the master's application. So primarily, you would want to have an undergraduate degree in a Bachelor of Science in Engineering, Math, or Hard Science from a regional accredited university. As we mentioned, if you don't happen to have this type of degree, you can always reach out to us individually and we can kind of check your background, resume, and obviously make that recommendation if you would want to get into the grad certificate. Obviously, after finishing the grad certificate, you apply again and you would get your master's program admissions, but you first have to complete the grad certificate, and that's for special cases. But traditionally, these are just the basic requirements. So obviously entering your digital official transcript, making sure you have a cumulative undergraduate GPA of at least a 3.0 on our 4.0 scale. And as we mentioned, this degree is kind of geared for working professionals, but also full-time students are available. So industry experience is recommended, but not required. This year for 2023, the GRE is being waived, so it's not required. So it is a great time to apply, especially for those of you that kind of didn't want to do a GRE, but obviously in future years, it might be required. So just FYI, you do have to submit your resume, a cover letter, add a personal statement, and then make sure you have 3 letters of recommendation. For international applicants, you have to obviously have those exams right there, and then obviously make sure you have all the same requirements as the other students. But make sure you go through these checklists and you submit all documentation whenever you're applying for any of these programs, because we won't make a decision until all the documents are obviously submitted, as this is a holistic review application. So we want to make sure all the details are being covered and that you're able to, express any concerns or anything you want to let us know in that personal statement or in your resume. But if you have any questions specifically before you apply, it's always helpful if you reach out to me and we can always kind of tackle any questions, and then I can always lead you in the right direction of how to kind of move forward or just outright apply right away at that moment.
Thanks, Luis. Would you like to continue with the grad cert as well? I mean, I would.
Yeah, go ahead.
They are the same requirements
Cool.
between them. So we'll just kind of go past these as well. Okay. So, following on to, the next question, which I'm sure, a lot of, prospective students do kind of want to know, either, what are the job opportunities are available, either if they are currently working, but they kind of want to make a transition and a pivot, or even for full-time students, who want to, get a job,
Absolutely.
post graduation.
Absolutely. So yeah, so one of the things that I wanted to share with you is that I constantly keep in touch with industry, because what we want to do is to make sure that when people graduate from the program, they are in high demand, that people will want to have them come work for them. And because of the uniqueness of the way we teach, how we teach, and what we teach. So anything about a program, you have to look at from two perspectives. What is it that you teach in that program and through the courses, and how do you teach it? And the combination of the two is what gives you that competitive advantage in your interview. Now, if you go back to the next chart,
Yep.
yeah, the skills that are in high demand right now in industry are system architecting is in big demand. Whether you're talking about in business or you're talking about in technical fields such as aerospace and automotive and things of that nature, manufacturing, telecommunications, it's always there. Systems thinking is a very big thing, and it's not just in engineering, but in just generally in any course. It's a very valuable thing. The fact that you have that kind of background, it helps a lot. System integration and system of systems integration is becoming very important. When we start talking about complex systems, integrating them, using cloud storage, using cybersecurity, all that kind of stuff. So you need to understand how to integrate these various people, specifically how to integrate legacy systems that you have to bring into the picture, and how that might interfere with an otherwise pretty good architecture that you've come up with, but that cannot support the legacy. So you've got to go back to something else. Then the integration with humans, human system integration. How do you have to compromise on the architecture to accommodate the human so that the joint performance of the human machine system is great, because you're no longer focused on individual performance of either, but the joint performance of both. Then, of course, you have the notion of how do you prototype a concept of operations to show your customers what you're trying to do with the system, how it's going to work, and things like that. So we share with you those ideas, how to create a test bed, and how to create virtual prototypes and things like digital twins of a system that you're trying to build, and things of that nature. And also a digital twin of an existing system that you want to analyze in terms of its performance, in terms of its maintenance requirements and things of that nature. Then, of course, model-based system, no, go back to
Sorry.
Model-based system engineering is a very important subject. Just about every engineering department wants this in the students. And of course, then simulation-based modeling and analysis. Okay. And then, of course, then you have the usual things like agile development and lean operations. So these are the skills in demand, and we covered these skills in our program. Go on to the next. So my students that have gone on from the program have been successful in getting jobs in aerospace and automotive companies, federally funded R&D centers and national labs, medical device companies and healthcare organizations, web companies, as well as state and city organizations. So we have a lot of students that come from Boeing, and Boeing is one of our preferred customers. Northrop Grumman is a very important one, Raytheon, SpaceX, General Motors is a very important one, and also Tesla. When it comes to FFRDCs, which stands for federally funded R&D centers, we have a lot of students coming from Aerospace Corporation, Jet Propulsion Lab, MITRE, and RAND Corporation. When it comes to the medical devices area, we have people that go and get jobs at Medtronic. So when I describe these names of these organizations, I'm saying our students have graduated and gone on to get gainful employment at all these different organizations. So in the healthcare organizations, primarily the people that are interested in that, the students who are interested in that field, they go on to work for the Kaiser Permanente or the Veterans Administration or something of that nature. When it comes to people who are more interested in kind of IT type work and web kind of work. Many of them are now employees at Google and Amazon and Facebook. And so that's been a very fertile ground for placing our students. And then when it comes to places like state and city organizations, we send our students to Port of Los Angeles, the Los Angeles Department of Water and Power, and such. So there's a large, you know, swath of employers out there that hire our students, and they vary from in various industries and various organizations. So we cover automotive and aerospace and uh, telecommunications and transportation and healthcare and medical devices and web development. So the SA program produces people that are in demand at all these places. Now, one thing I did not mention, but that I do want to mention is important. Several of the students that come out of here go on and do startups. So they start their own companies. And they've been quite successful because being a multidisciplinary program, people that graduate from here know what are the kind of skills that they need, and they're able to hire people from different disciplines because they have enough of a understanding and knowledge about that they can do startups. So that's another piece that I want to share with you. Let's go on to the next.
Thank you for that. And so, can I pursue the programs online for the systems and architecting engineering programs?
So yes, Luis, you can take over.
Yeah, so for now, all of our programs are offered online. As we mentioned, the graduate certificate and network-centric system will be removed. So for the other programs, our master's and our 2 grad certificates that are active, they're fully available online through our DEM platform. So you could be anywhere in the country. We have a nice DEM platform set up for you all where you can have engagement, obviously have access to recorded lectures. That's where you'll access all your homework and assignments and readings. And then obviously you can always come in and sit in live lectures if you are out of state student and then just want to come visit Los Angeles campus. And then you always have those opportunities. So it is mostly for online students, working professionals out in the field. So you kind of see most of that population doing it online.
Thank you, Luis, for that. And I think that's a great segue for me to kind of take over and go through the different course delivery method. So, as we mentioned before, there are mainly kind of 2 types of course delivery on campus for people who are going to be on campus, and then also online via Dan at Viterbi, which is kind of more tailored towards working professionals. And so, how does Den at Viterbi work? So, Louise did, touch upon it very, very well, that it is the online delivery method. And it is actually Viterbi School of Engineering's own state-of-the-art proprietary web-based delivery system. And it does allow, students from all over the world to be able to access classes in 2 ways. Either live as it's happening, so, you are able to call in and stream and, chat and have conversations with professors, or, you can watch it afterwards as a recording, because, as we kind of touched upon that, a lot of the students of the systems and architecting program, do tend to be working professionals. So they do work full time and then they watch it as a recording afterwards at a time that does suit them. So as a Dan at Viterbi student, you do still view the same lectures as on-campus students, and the content is fresh every semester. So, our professors do really want to ensure that they are providing the most updated information and content for our students, either bringing them from outside, from work industry, into the classroom, so then working professionals can apply it to their day-to-day job. For example, you do participate in highly interactive discussions with professors and peers, and you do submit your homework electronically as an online dance student. But when it comes to exams, you do take exams at a proctor testing center in person, either near your home or your work, or if you are located around the Los Angeles area, then you would be coming into campus to take your exams. And so, in terms of the general admission criteria, so, Louise did, go through this. So, I'll just kind of, so It is exactly kind of what he said, in terms of what you need to submit. So yeah, please do ensure that you do submit all your materials together. Otherwise, your application won't be reviewed until everything is submitted. And, just a quick comparison, for those of you, who are joining us either online or watching it at a later recording, what the difference is between an online Dana Viterbi student versus a on-campus student. So the program admission, it is the same in terms of completing the application and the required materials that you do need to submit. The lectures, for online students, they are online with interactivity, and on-campus student would be in person. So you do need to attend lectures in person. But, in terms of, whether you will have access to the recordings afterwards as an archive for on-campus students, it does really depend on whether you are enrolled in a DEN section. So if there is a Dana Viterbi student in your class, then you would have access to that. Otherwise, you wouldn't. Assignments, I kind of mentioned before, you would submit it online as a DEN student, and then on campus, you would be submitting it during the lecture or lab. And then, exams are proctored for online students, and the on-campus students is on campus. In terms of, courses per semester. So, courses per semester for online students, since they do tend to be working professionals, they do tend to take fewer courses per semester. And then, the degree completion requirements are the same for both. So ultimately, your USC diploma will be the same, and it won't have a distinction of whether you are an online student or on campus. And some additional Dana Viterbi additional information, so we do have a enrollment option called limited status. So limited status is where we allow, strong candidates to have a jump start in taking a course or two before they apply for formal admission into a either graduate certificate or master's program. You do need to have a 3.0 GPA on a 4.0 scale to be considered eligible. And, you can only take a maximum of 12 units before you would then apply for formal admission. You can get started as soon as summer 2023 if you want to, although we are still accepting admissions for Dana Viterbi students for fall 2023. And we do also have a employer reimbursement deferment program, and this is for students who are supported by a company in terms of tuition assistance. You are able to defer your payment of up to 90% until the semester is over. To be eligible, your employer does have to reimburse you for tuition, and your student account does have to be current. For additional information on this, we do encourage you to go to that website indicated on our page. Okay, so, another frequently asked question that we do get is, okay, so I have decided to pursue a graduate program in systems architecting and engineering. So, any tips on getting started? So, if you decide that, you're ready to start your application, so as I mentioned, we are still accepting applications for online Dana Viterbi students for fall 2023. We have extended the deadline to May 31st. And so, this is for students who do not require a student visa sponsorship and who do plan to pursue the program in its entirety online. So we do encourage you to submit your application before this deadline date. But for those of you who, need a little bit more time, or you decide to apply for a future semester, the next one would be spring 2024. And, the deadline to submit your application for that would be September 15th. But, if you do need an extension as a DEN student, please do email me at danaviterbi.usc.edu, and I'll be able to work with you on that. And then after that, we do recommend for you to go back onto our website and go to our program overview page, especially for those of you who are watching this recording at a later date. Please do refer to our website for the most updated admissions requirement. Because, as Luis has mentioned before as well, things do change. And for example, the GRE may be a requirement in future semesters. And just here are just some useful links for you to get started. You know, if you are interested in taking classes on campus and you want to visit the USC campus, you know, we do have a team, you know, who could also, you know, assist you with that, or you could attend virtually as well. But, you know, either way, you know, if you decide to apply for formal admission, then you do need to submit a application. Okay. So, you know, now let's go ahead and go to our Q&A section where we will have, you know, Professor Mani and Louise as well to be able to answer any questions that you guys might have. But so I guess, you know, while people are typing in their questions, you know, I do have a question for you, both Professor Mani and Louise. So, you know, are there opportunities for students to do any, let's say, research or thesis based, you know, like projects as part of the coursework as either a on-campus or online student?
Okay, so take a course like SA 549. People are supposed to create a term paper and submit that at the end, which is the maximum percentage of their grade. And for that particular course, you're doing research, whether you're on campus or online, it doesn't matter because you have to review a bunch of stuff and come up with a way. And to give you an example, the kind of research you're doing is you pick a system that already exists for which there's ample data, and you try to reconstruct how the architect went about creating that system, what was the architect thinking, what decisions did the architect make, what assumptions did the architect make, and things like that. And so that's a really great way of researching an existing system in terms of how it came to be the way it came to be. And it really helps people to see how things were architected. So that's one area where you get a research opportunity. The other thing is we have a distributed autonomy and intelligence systems laboratory that we've had where we work with digital twins of you know, robot cars like formula cars, and with you know, small UAVs and things like that. And in some cases, students who would like to pursue research as part of their master's program get a chance to work and do research, you know, with us in that area. Now, most of the PhD students that we have, they work in our lab and they essentially use the ground vehicles and the, you know, the space borne vehicles like unmanned aerial vehicles, small, you know, micro UAVs, you know, like quadcopters, and they get full hands-on experience with that in programming them, controlling them, trying out different algorithms and such. So yes, those are opportunities. And then of course, with the other courses in model-based system engineering, you get a chance to research different methods and different tools and the pros and cons of the methods and tools and things like that. So yeah, there is a research element in the educational components. Yes.
Dr. Madni, if I may add, do you allow the students to pursue a thesis in the master's option to possibly pursue
It's
and
very
continue?
rarely done. It's seldom asked. Um, but every once in a while, we've had that situation. In the USC programs, master's degrees are mostly all course-based. But
Correct.
on rare occasion, if some student has a specific exceptional need to have a thesis done, then you know we can try to make an accommodation for that. Now, when I went through my master's degree at UCLA, and that was in the 70s, you absolutely have to have a thesis if you want to pursue a PhD. But those kinds of requirements have gone away, and now thesis is just some people saying, "I'd like to do a thesis because I'd like to get some research." They can also do what's called directed research. So they can take 2 units of directed research in a particular area, and based on, you know, how well the research fits into the overall program, we can make an accommodation on that as well.
Sounds good.
Great.
Marilyn, I see a few questions here, but this one, I don't
Yep.
know if you would be able
I
to
could
help.
go ahead.
The
Yep.
first one is, do you know
Thank
the
you.
timeline for an admissions decision
Which one is?
from Camden? He asked, he applied
Oh, I
already in
haven't
fall
seen that one.
23.
Okay.
Do you
Can
know
you
if
read that out to me?
he said, I have already applied for fall 23 with the required materials. Do you know the timeline for an admission decision? So I'm assuming he's just waiting to see if he gets admitted or not.
Okay, great. Yeah. Thank you for that question. Yeah, so usually upon your application completion of making sure that all your required materials are submitted, we do ask that you allow 6 to 8 weeks for the graduate admissions team to review your application. So and after that 8 week time frame, if you still haven't heard, feel free to reach out um, to us, either if you apply for the on-campus or if you're an online Dana Viterbi student, I could go ahead and, follow up on your behalf with our admissions team to kind of see what that status update is. So thank you for reading that out, Louise. I didn't see that. So there are some other questions that some of them I could answer. So I will be sending a copy of the presentation out within 1 to 2 business days. Okay, so here's another question. So my last degree was a bachelor's in computer science and engineering from UCLA and awarded in 2001. Would I need to find a way to obtain my transcript? So I could go ahead and answer this, and then if you, Louise, want to add on as well. So to answer your question, so yes, you do need to submit all official digital transcripts from all post-secondary academic institutions. So, unfortunately, even if it was back in 2001, you do need to request that from UCLA. Otherwise, and it does have to be official, official in the sense that, it is granted by your institution with the watermark and the letterhead, and that it does say official on it. Otherwise, if it is unofficial, it will not, your application would be considered incomplete. Okay, there's a question for you, Professor Madni. So I'm wondering if you could talk a little more about model-based systems engineering. I noticed there are some SAE elective courses. Do any of these courses delve more into simulation and model-based systems engineering?
Sure. So model-based system engineering is something that came into prominence, I would say, about 15 years ago. And what it is an important aspect of system engineering. Initially, it focused on the front end of system engineering, and now it's starting to spread across later stages of the system lifecycle. The key point here is with model-based system engineering is that models are the central and the authoritative sources of truth. So models are authoritative sources of truth. The beauty of that is that you have compatible assumptions, you have representations and different perspectives that come together. You have it's different from engineering with models, where you take third-party models and try to integrate them to create a solution, but you don't know what assumptions those models made. You don't know what algorithms they employed, whether these assumptions are compatible when you try to integrate them or not, whether those models are compatible when you try to integrate them or not. You don't have that issue with model-based system engineering because it uses model as the integrated central source, authoritative source of truth. Now, yes, we talk about modeling and simulation. We talk about simulation from two perspectives. We in our courses we cover discrete event simulation. We cover agent-based simulation. We also talk about system dynamics, and of course, we talk about how models can be executed in virtual worlds using a game platform like Unity, for example. So we do cover model-based system engineering, not just from the point of view of the modeling aspect, but also technology aspect. What technologies can we bring to bear? I have, in fact, several papers on that where I talk about how storytelling from the entertainment arts can be incorporated into model-based system engineering. And if you Google my name and put down model-based system engineering, you will see a bunch of papers pop up, and many of those papers will address these various aspects that I'm describing you. And when we, in our courses, I provide all those courses to the students, in PDF format, so they have access to everything that is latest and greatest. I also have just finished a handbook of model-based system engineering. It's a 2023 release that has approximately 50 chapters written by preeminent people from all across the world. And so people from Jet Propulsion Lab, MITRE, MIT, Georgia Tech, USC, they're all there. And you can, if you have access to the libraries, then you can probably download those chapters, if your companies have those access. If not, you can, purchase a chapter, or if you belong to a particular, membership club or something where they provide that for free, fine. But in my classes, I make those things available for free to my students when people are enrolled in those classes. I also have a couple of other edited volumes in the journal called Systems on Model-Based System Engineering. And the very first paper on Model-Based System Engineering from, I think it was 2018, if I'm not mistaken, in the INCOSE Systems Engineering Journal is written by me and my colleague, Michael Sievers. So if you just Google my name and put down Model-Based System Engineering, all these papers and publications should pop up. And if you have any difficulty, send me an email. I'm very happy to send that information to you.
Thank you so much, Professor Madni, for that. Okay, so I think I don't see any other questions. So, I just wanted to, thank you, Professor Madni and Louise, so much for, for joining today's webinar, the Spotlight, and just talking about the systems architecting and engineering program. I found it, very, very informative, and I'm sure, our audience has also found it informative as well. So, thank you so much. And, for all of you, who are attending, if you have any questions, feel free to reach out to me, and I could also, direct your questions, to Professor Madni, or even to Louise, and then I can go ahead and reply back to you guys on your questions. So, thank you so much.
Nathan thanked me, and I want to thank Nathan. Nathan, I want to tell you, you're very welcome. And if you have any other questions, feel free to contact us. Take care.
Thank you. Yeah, take care, everyone. And at USC, we say fight on.
Fight on.